everyone. Today's video is to demonstrate our embedded system project for X373. I'm Jia Chen. This is Hongji. And Wing.
Hi, my real name is Sararajanamokun. Nice to meet you.
And of course also Zhe Zhang, who is currently taking this video.
Hello, I'm Z.
First, a brief introduction. Our project is named Mr.Li-Fi, which is a visible light communication system. Here is how our project looks like. We managed to send data through this LED by turning it on and off, and then the sent data will be captured by this photodiode on this side. Here is the idea behind our project. Essentially, all the information or data to be transferred can be converted into binary, and therefore we use this LED on for sending 1 and off for sending 0. As you can see, our project is made of 2 parts, the transmitter part and the receiver part. And the data to be transferred can be taken from the keyboard from any PC and then displayed on the LCD screen from the receiver part.
Next, I will explain about the transmitter part of our project. So the 3 main components of our transmitter part are the computer connected to the Smart Fusions and the Smart Fusions connected to the LED. So first we need to create the interface between the user and the Smart Fusions such that the user can type in the words they want to transmit, for example, hello world, and send it to the Smart Fusions so that the Smart Fusions can blink the LED to transmit the data. So in more details, inside the software of the Smart Fusions, it will receive the characters from the computers through MMS UART, and it will keep receiving the characters until it receives new line characters. And once it receives the new line character, it will pass those values to the hardware side of the Smart Fusions, where in the hardware, it will receive the binary values of the ASCII characters and transmit it at the rate of 2000 bits per second. And the protocol we use to transmit the data is based on UART. So when it's idle, not sending anything, it will just keep sending 1, as you can see, just light on, doing nothing. And once we want to transmit the data, we first need to send the start bits, which are 0, 1, 0, followed by the number of character we are going to send, followed by the ASCII value data.
Next, I will talk about the receiver part of our project. In our receiver part, we have a photodiode to sense the light variation of the LED in our transmitter part. Since the light variation is in the form of analog, so we use our onboard ADC converter of our Smart Fusion to convert the analog signal into its digital form. And in our software, we have a sampling frequency which is 25 times faster than the transmission frequency, which allows us to do some advanced error checking and redundancy checking. And finally, in our software, we convert our received binary bits into ASCII characters and using the onboard UART to display the characters on the LCD screen.
Nice. There are also 2 more things worth to mention about our receiver part. First, there's a lens which is used to focus the light so that the photodiode can get a better signal. Also, there's a servo next to the LCD screen which is used to find the optimal light source from the transmitter. In this case, once we press the button on the FPGA, it will scan entire horizontal surface and go back to the best position, waiting for receiving the data. Next, let's do a quick demo of how our project works. You can see from the previous demo, our system is both accurate and stable, and it only costs less than $10. So for the future development, we can try to increase the distance between the transmitter and the receiver. And also, we can try to increase the frequency of the transmitter. For the application, I would imagine our system can replace the Wi-Fi so that it can send any information you want, including the internet package. It can also use as GPIs if you replace the street light with the blinking LED. Alright, that's all I have for today's video. Thanks for watching and no need to subscribe.